We're going to be taking a look at cryptography, and in the next video we'll look at a specific example, which is going to be RSA cryptography, and that one you can actually solve some mathematical problems for it. So if you have a computer science course like discrete math or something, that one you will see that you actually have to solve RSA cryptography most likely. So we'll see how to do that in the next video. So for now, let's just take a look at the general idea of cryptography and some of the problems we can run in. So go ahead and let's design a situation, and I guarantee if you've taken a course on this, you have seen this situation with the exact same characters because nobody is original. So we have one person over here. Let's put this person as a female. We'll call her Alice. And over here, you'll have Bob. And sneaking in the bushes, let's actually go ahead and draw a bush just because I want this to have details. I don't have the right color. Okay, whatever. This is not a good color for a bush, but we'll go ahead with it. And here we have somebody who is sneaking, right? This is going to be Eve, right? And the reason why this person is always called Eve is because of the word eavesdrop. And every professor you have will try to make that joke, and you are going to be forced to laugh at it. So Eve is hiding in the bush. She looks like a witch. And she wants to intercept the message that Alice is going to send to Bob. Now, the way this could be avoided is if Alice encrypts the message, right? To have something to apply the message to make sure that unless you know how to reverse it, you will not be able to uncover the message. Now, a way that this is normally written, let's go ahead and write this here, right? That what you want to pass is M, right? That's simply going to represent the message. So whatever the message is going to be M. Now, if we go ahead and encrypt the message, we'll call this here. This is going to be the function. This is going to be the encryption function. It's essentially going to be whatever technique you're going to apply to the message to make it look like something else, right? To make it non-understandable, if you will, by Eve. So if we were to go ahead and do that, this is the function applied to whatever message Alice wants to send to Bob. Well, we're going to get this over here, which is going to be representing the encrypted message. So this is normally the standard notation you're going to see. So if you see it, this is what it means. If we have F, which is going to be the encryption function on the original message M, you're going to get back the encrypted message M with the little symbol on top of it. Now, if Bob receives this message and he has the decryption key, he knows how to decrypt the message, he will actually be able to apply the inverse of the encryption function to the message, which is actually just here, which is F of M. Obviously, this is obviously the same thing as using the inverse on the encrypted message right there. So he will have a way of completely reversing the message. Now, what are some ways of encrypting this message, right? We've looked at all this crazy notation right now, and we haven't really even talked about what was going on. Now, the thing they can do is they could agree on how they're going to encrypt it, right? So let's go ahead and write out some techniques that they can do this. Number one, they could agree on an encryption method. The problem with this is that they will have to have previously agreed on the encryption method for it to work, right? They need to know how to encrypt it and how to decrypt it. And this is a catch-22, right? They cannot send the encryption method to each other. If they cannot meet up together in a public space, then they cannot do this. So if they're on separate parts of the world, they would have to have sent the encryption method unencryptedly to the other person, and that could have been intercepted by Eve, and then she would understand how to decrypt any further messages that she would intercept. So that's a problem right here, right? This is not going to be a good option. Another way is that they could use, let's say if it was an actual message, they could just use letter frequencies. They could just go ahead and change the message. So what if they shift the letters? Shift the letters over. What if A became C and B became D, and let's go with C became E, and so on? Well, this would also be busted as well because there's a natural letter pattern in the English language. The letter E occurs a lot. And Eve would be able to look at this and see which replaced letters occur often, and then she'd be able to figure out that those are likely E. And then she would see 3-letter words that end with that new E, and those would probably correspond to the word the, and then she would have T, she would have H, and by that she would be able to work her way through the message. So regardless of which way you're replacing letters, the problem with the English language is it's not going to let you do this. So we have a bit of an issue here. We have, no way of these two people, as long as if they can't meet up with each other, there's no way of them agreeing on an encryption method and it being safely transferred between them. So what is a way that we could technically have two people who do not meet each other to be able to have a way to send messages to each other? Now here's how we would do this, right? Before we actually get into the specific method, this is how we would actually go ahead and do it. So let's go ahead and draw a scenario over here. We have Alice and we have Bob, our two characters. Now she has the message over here. She has M. Now what she's going to do is she's going to go ahead and apply a lock that only she knows the combination to. So she's going to go ahead and she is going to put a lock on this. This is the Alice lock. So she is going to attach this lock to M, and then she is going to send that to Bob. So the message is now locked. Bob cannot open it. It has the lock from Alice on it. So I'll put the lock down here. It is locked. Now you might say, well, he has no idea how to unlock this lock. How is he going to be able to do anything? Well, he is actually going to go ahead and he is going to apply his own lock as well. So there's going to be 2 locks on it. And he is going to take this and he is going to send it back to Alice. Now Alice is going to have the message, and this message is going to have Alice's original lock and the new lock that Bob placed. So she has no idea how to open up the Bob lock. She only knows how to open up her own lock. So what she's going to go ahead and do is she is going to go ahead and cross off her lock, and now it's only going to contain Bob's lock, and she's going to send it all the way back. And now Bob obviously knows how to unlock his own lock. So we have the lock over here. And he will know how to take it off. And now he has the message with no encryption on it. So that is a way that two people who will never meet up, who have no way of agreeing upon a encryption system, and two people who have information that is too sensitive to risk using the shifting of letters, right? The thing that would get busted by the English language. This is how two people can send a message to each other. In the next video, we'll take a look at RSA encryption, which is how essentially you could do transactions on websites, right? You can send secure information to websites online, and that's actually pretty cool. And there's math behind that one, which will likely be on any exam you take in a course that has anything to do with encryption. So you want to know how to do that. So I'll see you guys in the next video.